Hello, everyone. In this lesson, we're going to continue to show you what kind of questions you will see in calculus on the algebra part. For this set of questions, okay, still it's about simplifying, and in particular, we're gonna, express it in factor form. Okay, we want to have a factor form. Because in that certain chapter of Calculus 1, you will need to factor these forms. And these are the questions that are directly from calculus text, okay? I would like you guys to follow me and to factor these questions. The previous lesson, you have seen factoring the rational functions, right? And those are questions from calculus, and these questions are also from calculus course. All right, let's start from the first one, okay? This is the simplest one. The general rule of thumb, okay? General rule of thumb to factor it out, to make this a factor, is to factor out the one with the lowest exponent. Okay, so I'm going to write it down. The general rule of thumb, okay, the general rule of thumb is to factor out the term, okay, or the factors, factors with the lowest power. Sorry about that, power. And in the first question, and there's only one power, which is negative 2/3. So this is the one we are going to factor out. But how do we, we don't have the same power in the first term. So how do we factor it out? So we're going to make it. We're going to make it. How do we make it? Okay, how do we make it? The way we make it is actually we use a property, okay, in algebra. There's a property in algebra says b, a base raised to power 0 is equals to 1. Okay, of course, base cannot be 0. And how do we use that, right? So base to the power of 0 equals to 1, but 0 is it could be created in many different ways. So for example, 0 equals to 1 minus 1, right? And 0 is also equals to, let me write it down. Let me finish this part, okay? So I'm going to put this on the node part. Okay, so b raised to the power 0. So on the node under, okay, so please have your paper pencil with you so you can work along my side. Okay, these are the things that you have to do it. You can't just watch it. You have to do it. Okay. So if we write it this way, of course, 1 minus 1 is 0, right? And how are we going to break it? Break this? Well, when we try to break this, we're going to use the other property, which is b raised to the power of m plus n is equals to b raised to the power of m multiply b raised to the power of m. So we're using this property. So from that, we can see that if we treat m as 1 is m, and n is -1. So b to the power of 1 minus 1 can be seen as b to the power of b plus 1 plus -1. So now you see the correspondence, right? So in other words, we can write it as b to the power of 1 multiply b raised to the power of -1. So the same scheme can be played out with any power of your choice. For example, in this case, right, 1 can be written as b raised to the power of 2/3 multiply 2/3. 2/3. In other words, I can write it, this is b raised to the power 0. And that equals to 1, provided, b is not 0. And on this part, we can do similar things like we did earlier. So we can write b to the power of 2/3 multiply b raised to the power of -2/3. Once you get to this point, right, you can go ahead to do factoring. Okay, so now because we want to factor out x raised to the power -2/3, right? So we don't have x raised to the power -2/3 on the first term, so we're gonna make it, right? So we're gonna write it as x raised to the power of 2/3, okay, multiply x raised to the power of -2/3, okay, minus, what we had before. So we did not change the second term. We merely just to make the common factor, okay? At the same time, this piece is still equals to 1. So the first expression is still the same as the second expression, okay? Because we're not going to alter the expression. We're just change the way we write the expression. So now we can finish the factoring. So we're gonna bring this one out because we have a common factor here, right? So we have a common factor here. And this piece is factored out, right? This piece is factored out. So we get that. So it's factored out, okay? And then what? And then what? How about then you say, how about 1/3, right? What if we just take out the 3? Yes, we can do that, right? We can do 3/3. Okay, because after all, we don't want to deal with fractions. If we can put it away to simplify it. So this way we will have 3, right? Because we're going to factor out the 3. So this will be -1, and we're going to put 1/3 outside. So these are just make sure what's in the parentheses can be simple enough. So by this time we get this form, we factored out the factor with the lowest exponents. Okay, and you can also bring this one to the front. Now the next question is, can we factor this further? We could, okay? If you want to, I'll just show you a couple of things you can do, right? You can factor this because we can see this as x raised to the power 2/3 as x raised to the power of 1/3 squared. Okay, and the parentheses outside, we're going to use a bracket. Okay, doesn't make any difference, but it just makes it easier to see. And this way, right? Then you say, well, can we continue to factor? Yes. If you think about 3 can be written as 3√3 in parentheses. Okay, so we got square here, square there. So we can bring this √3 inside. So we have parentheses squared minus 1, and 1 can be seen as 1 squared. Whoops, sorry. Okay, 1 can be seen as 1 squared, right? So that way, we're going to finish the factoring to the simplest possible. Okay, so this piece, so we're going to use this factor form, right? A squared minus b squared equals to a minus b times a plus b. You can write them any order you want. So on the bracket part, we're going to have a minus b multiply a plus b, and that's considered completely factored. Okay. So I'm just basically using this example to show you the factoring, how much we can do on factoring. Of course, there are other alternative methods that we will address for those calculus situation. Okay, so let's look at the second question. On the second question, we're going to be using similar techniques. Okay. In this case, the lowest exponent is actually x raised to the power -1/3. Okay. As a matter of fact, I did not indicate in the first one the domain. So let me come back to get that done. Okay, so the domain here obviously is x cannot be 0. Okay, sorry about that. Okay, because negative exponents, so x cannot be 0. Okay, sorry about that. Now we're back on the second question. The domain is odd number roots, right? So the domain is, once again, x cannot be 0. So how do we factor it out, right? We are going to observe, we're going to use our rule of thumb, factor out the factors with the lowest power, right? With the lowest power. So we're going to do the same thing. So x raised to the power -1/3. But on this one, we don't have it. We don't have x raised to the power -1/3. So there are a couple ways to do it. One way is that you do what we did before, right? You will multiply x raised to the power 1/3, and then multiply x raised to the power of a -1/3. So essentially, where we know that from our previous example that this is just equals to x raised to the power 0, which equals to 1, right? So it doesn't change the nature of these two expressions, which they are still the same. Okay, so we're going to put that reason arguments over here. Okay, it's optional because anybody who read this would understand. It's just because I'm explaining it to you. So this way, we can factor out the x raised to the power of the -1/3. So now I'm going to bring that out. Okay, so x raised to the power -1/3. Inside and parentheses over here is 1 minus. At the second term, we have this, just the product of these two left. Okay, and then we can add these two exponents. And what do we get on the next step, right? 5/3 plus 1/3. 5/3 plus 1/3, that's 6/3, right? So that's going to be 6/3. That's 2. It's looking up, right? It's looking simpler. And then we continue the factoring, right? So this part can be factored as 1 minus x times 1 plus x. Okay, so domain is determined and that's factored. The third question, okay, you can see we're pretty much using the similar tricks. However, I do want to show you another alternative before we do number 3 is on this one. Okay, there's another way you can do this. There is. Okay, there is, because once you understand the nature of this question, right, you can write it as 5, 5/3. 5/3 is 2 minus 1/3, right? That way you can factor it out. You can factor out the negative 1/3, right? So you will get the same thing. You would get the same thing. So once you understand the power of operation with, the operation with powers, we learning algebra and know how to use it in this situation. Of course, there are more than one way to do it. Okay. All right. So let's look at number 3. Number 3, let's take care of domain first. But this time the root is a 4th root. The domain, this is the 4th root, right? Unlike previous situation, it's root 3, and we have a root 4 here, right? Because we understand that root 4, right? Root 4 of x, the domain needs to be x has to be greater than or equal to 0. It cannot be negative. But if it's a negative, right? If you get 1 over root 4 of x, then the domain would be x greater than 0 because denominator cannot be 0, right? So that's the situation we have here. So the domain for this one would be x must be greater than 0. Okay, so even number root, odd number root, so we have to make that distinction. We have to make that distinction, okay? So odd number root, even number roots. So we got an even number roots. And next, we are going to simplify, okay? We're going to simplify. So how do we, well, we're going to use the rule of thumb. We're going to factor out the lowest power, right? So let's try to factor out the lowest power. And this one certainly does not have it, right? We have the lowest power, which is at x to the power negative 3/4. And this one is 1/4. So what we're going to do is that we're going to have x raised to the power of negative 2/4. That will make, right? And you also have to multiply x raised to the power of positive 2/4. So this way, that makes 1, and these 2 makes x raised to the power negative 3/4. You see that, right? So you have to do some operations with the fractions. You have to do some operations with the fractions. But now, so these 2 combined, right? That's going to be negative 3/4. Okay, negative 3/4. So now we can factor this out. And we also want to factor out the 1/4. And so what do we get here? What do we get here is that we're going to factor out. Okay, so let me write it down. So we're going to factor out the 1/4. We're going to factor out the 4 from the denominator, right? So this would just be 3 left. This would just be 1 left. And this piece is taken out, right? So it'll be 1 left. We're going to put it here. And this piece is gone. 2 quarters is really 1/2. Okay, it's really just 1/2. So our next step, you can write it as 1/4. Okay, you can write it this way. Okay, x. And over here in this parentheses, to see better, right? X raised to the power 1/2 is really root x. It's really the root x. Okay? And domain has been determined. The domain has been determined. All right. The next question is somewhat similar. Anytime during the lesson you want to do it yourself, feel free to do that. But one thing is certain, you must practice to work with these kind of expressions. Okay. Next one. Obviously, the lowest power is -3/4 again. The denominator 4, right? We're going to use pretty much the same trick. Okay, so let's go just a little bit quicker. And this part is -3/4. So we got that. I think the only difference is here that we're going to have a slightly different number inside the parentheses. Okay, so you can write this 1/2 over here. Okay, and then we're going to factor out the 1/4 x raised to power of -3/4 parentheses, right? So we're going to have a 3 times x raised to the power 1/2. That's root x, square root of x. And here, instead of subtracting 1, we're going to be subtracting 2. I think these two questions just has little difference. Okay. Number 5, actually, there's not too much to be done. Okay, the domain is also the same. Number 4 is the same as the domain for number 3. So we're gonna pass that quickly and let's look at number 5. On number 5, actually, there's not too much to be done. The only part that we can do is to factor the inside. Okay, so this one actually is a pretty simple one. We have a -2/3. Okay, x here. And inside here, if we want to factor, we can get 2 minus x, 2 plus x. All of it raise the power of -2/3. There we go. Okay, but that's enough. That's enough. Okay, domain-wise, let's look at the domain here. It's odd number root. It's odd number root. So the denominator should not be 0, right? So this should not be 0. So when we determine domain, 4 minus x squared should not be 0. It can be negative because we're taking, odd number root. And if that's the domain requirement, we're getting x squared not equals to 4, right? And we take square root on both sides, and then we're going to get absolute value of x not equals to 2, and in the end, x should not equal to plus 2 nor minus 2. So that's the domain. Okay, so that's the domain for the function in, number 5. Okay, so that's done. Okay, so we have 3 more to go. Number 6 is odd number root again, but we have 2 factors. We have 2 factors, right? So don't forget the rule of thumb. The rule of thumb is factored out the factors with the lowest power. Okay, so now we have 2 factors. One factor is x, the other factor is x minus 4. So we're going to factor out both factors, and we're going to choose the one with the lowest power. Okay, the lowest power for x minus 4, of course, is x minus 4 to the power of 1. And for the x, the lowest power is negative 1/5. Okay, so this piece, we don't have it, so we're going to multiply, right? X, I'm going to start a new line, okay, so we don't get confused. So we still have the original questions at hand. Okay, so the first term, we don't need to change anything. So we're going to multiply x raised to the power negative 1/5 and x raised to the power of positive 1/5. So this piece is 1, right? So we multiply by 1. Nothing changes. By doing so, x raised to the power 4/5 multiply x raised to the power 1/5, and we're going to add the exponent. Okay, so 1/5 is going to add to the 4/5. 1/5 plus 4/5, that's a 5/5. 5/5 is 1. So that part is simplified to be x. Okay, just to separate a little bit, right? Denominator 5. So now we're gonna factor things out. So I'm gonna do it this way. You can see we take things out gradually. I put a bracket. The first thing I'm going to take out, a 1/5. Okay, so 1/5. 5 is taken out. So this piece, we only have 4 left, and there was no, fifths before, so it's a 5 under 5. So when we take out the 5 under, right? So it's left with 10. X raised to the power 1/5 multiply x minus 4 is taken out. So that's been taken out. And that's been taken out. One of the x minus 4 is taken out. Right? You can see these things are being taken out. Now it's being factored out. Okay. So 4 times x minus 4. And let's simplify. The parentheses can be simplified. We're going to distribute 4x minus 16. So 4x minus 16. Combining like terms, right? So 10x and 4x, that makes 14x. Okay, so by this time we have factored that completely. But if you want to just do a little bit more, because you see there's 14 and there's a 16, right? So you can have this as take out the 4. I mean take out the 2 and bring the 2 outside. So this will be completely factored. Well, in calculus class, you'll find out what we're going to do this for. Okay, so make sure you practice with me. just do it along my side. When you do it once, you do it a couple of times, you understand, and then you'll be a master of it. Okay, so this is basically, in this lesson, we really talk about just one algebraic skill, which is a factoring. Okay, and yes, you will encounter these questions in calculus class. All right, this one. Did we talk about domain here? Yes, the domain. We get x minus 4 squared. And so the domain would just be x cannot be 0. X cannot be 0. Okay, now the next one. We're going to factor out the part with the lowest exponent. Okay, with the lowest exponent. We're just going to work on this part. Okay, if we need more factoring, we can do that. Okay, we got this on the second term. We don't have that on the first term, so we're going to do x raised to the power of, this is odd number roots once again. Okay, so we need x raised to the power of -1 multiply x raised to the power of 1. Because -1 plus -1/3, that's going to make a -4/3, right? So these two terms, actually, I want to keep the original question. Okay, that was the original question. So now these two will make x raised to the power of a -4/3. Okay, because -1 is -3/3, right? So this will make a -4/3, right? And this is x raised to the power of 1. We can omit the 1. And now we can factor. We can factor out the x raised to the power of x raised to the power of -4/3. Okay? The first term we have x left minus, and don't forget the 1/3, right? So let's bring out the 1/3. So that way we have a 3x here. Okay? And the next part, we have a x minus 2. So we're going to make this a bracket. Okay, I hope I didn't confuse you in any way. So the second part is x minus 2 tagging along. How do you know if we got it right? Reverse the process. Reverse the process. You're going to take this piece, multiply that. Do I go back here? Okay, let's check. 3 and the 3 in the bottom reduced. If I take this piece, multiply that piece and that piece, and I can go back. So you constantly verify if you get it right or not. Okay. So now we just have to combine the terms in the bracket. Oops, sorry. We just have to combine the terms in the bracket where we have 3x minus x plus 2. So that's going to be 2x plus 2, right? Because you have 3x minus x minus -2 is a plus 2, right? For that matter, you can take out the 2, you can factor out the 2, so you're going to have x plus 1. Simpler. Okay? Domain. The domain would be x cannot be 0. X can be negative, right? Because we have an odd number root. We have odd number roots. All right. Okay. Last one. This one is probably the more complex one of all 8 questions. Okay, but once again, we're going to use a rule of thumb. We have 2 factors. we have two factors. One is x as the base. The other one is 4 minus x as the base. Okay, x, 4 minus x. Their lowest power is going to be factored out, right? So I'm going to copy and bring it here, right? And we're going to work it. On the x raised to the power of negative 2/3, this is x raised to the power 1/3, and this is the lowest one. So we're going to try to make it on the other one to be the lowest one. So the other one doesn't have it, right? So you can write x raised to the power 1/3 into the power to be x minus 2/3, right? So x equals 1/3 equals x raised to the power of 1 minus 2/3. So these two are still equal. And then we can break it apart. We can break it apart, right? So we can write it as x raised to the power of a negative 2/3, right? And this is one power can be omitted there, right? So this piece is still the same as x to the power negative, x raised to the power 1/3. So that part is taken care of. For the base of 4 minus x, the lowest power is negative 1/3. And this is 2/3. And so 1/3 can be written at 2/3 can be written as 1 minus 1/3. So once again, we can break it into 4 minus x raised to the power of negative 1/3. So this piece equals to that piece. And this piece equals to that. So you can see we're just doing some algebraic manipulation. Next, we're going to factor things out. We're going to factor things out. We put all of these in the bracket, okay? We're going to first take out the 3 in the denominator, right? So that we're going to get 3. So this 3 is gone. So this whole thing is just that. This 3 is gone. So this would just be 2. Okay? And the lowest power, right? So we want to bring out x raised to the power of a negative 2/3. X raised to the power of a negative 2/3. So bring this one out. Okay, this is 1. Okay, we're going to bring out x 4 minus x to the power of a negative 1/3. So bring this out. Bring this out. So remove the dot. There. And this power 1 is not necessary. The parentheses is not necessary. And the last but not least, okay, they're being factored out. Inside the parentheses is a 4 minus 3x. Okay, you can put them in the parentheses if you want. And remove the bracket. That's it. It's done. But these probably are the hardest factoring questions and you have seen ever. Okay, I believe. Okay, especially you need some, refreshing on algebra. This might feel a little bit too hard, but you can start with the previous lessons and continue to practice. Okay, last but not least, domain. Because we have two factors, right? Negative exponent, so x cannot be 0. Okay. And x cannot be what? X cannot be 4. And that's it. We're done. Thank you for watching.
Ooh.